Hello students. We are going to solve problems on coplanar and concurrent forces, variety of problems, and in the hope that this will be helpful to you while you appear for your exam, both online and the regular exam. So here we begin with problem number 1. What you are given is a system of forces. All of them are coplanar and concurrent, they are passing through the origin. And you are given the directions also. In the form of angle, these forces make with x-axis. So you have force F1, F2, F3, and you are given the resultant of all of them. And that resultant makes an angle 50 degrees with the positive x-axis. You are to find out the remaining force. There is one more force, F4. And this F4, you want to find out its magnitude as well as its direction, meaning the angle which this force makes with x-axis. Okay, so R is given and you are given 3 forces. You want to find out fourth force. So how would you proceed? The way to proceed is this. Because you know R, the magnitude of R is given, that means you can resolve this force in horizontal direction as well as vertical direction, and there will be nothing unknown because value of 800, R is 800 and angle is also given, right? So you can find out what we can say the x component of resultant and y component of the resultant, right? And then you also know that there are 3 forces and the 4 forces. So all these forces can also be resolved in x and y direction, okay? So you can find out sigma fx and sigma fy. So logically, because the resultant of all these forces is this R, that means sigma fx, resolution of all these forces along x-axis, including force F4, and adding them algebraically will be equal to the horizontal component of R. Similarly, sigma fy will be equal to the vertical component of R. So let's begin with this. So what we say is, we will say Rx. That means, let me write it here. I hope this is fine. Rx. This is horizontal component of R, which is equal to sigma fx. Right? Sigma fx. So write down, so what is Rx? It is 800 cos 50. Right? We know that horizontal component is cos of the angle which the force makes with the x-axis. This is in 4th quadrant, the resultant R, and in 4th quadrant the axis is positive, and after resolution R is also along x-axis, it's going to be positive. So I can write it as plus 800 cos 50. This is the resolution of R along x-axis, and this has to be equated to sigma fx. Start with sigma fx will include F4 also. So start with F1. F1 resolved horizontally, it will be towards right, towards positive direction. So I'll write this as 400 cos 45. Similarly, come to F2. This is 300. Resolve it horizontally, cos 30 in negative direction. So it is 300 minus 300 cos 30. Come to 3rd force. It is 500. Resolve horizontally, it will be 500 cos 60 in negative direction. So minus 500 cos 60, right? So this is the resolution of all these 3 forces. But we need to consider the 4th force, F4 also. And we don't know its magnitude. We don't know the angle also. We'll treat angle as theta. Theta is the angle which it makes with x-axis. Right? And like any unknown in algebraic equation, this will be treated as unknown with positive sign. It might turn out to be negative. Let's see that. So in the same equation I am writing here, this is going to be F4 cos theta. Right? Cos theta, because we are resolving it in, so we don't know in which quadrant F4 is going to be. We'll find out that. So this is one equation, right? So we call this equation number 1. Then we write the second equation by, similarly we can say sigma Ry is, not sigma, I'm so sorry. This is not sigma, this is Ry, resultant of, vertical component of the resultant is equal to sigma Fy. So Ry is, you resolve it vertically, that means it's going to be sine of 50, sine of the angle which this force makes with x-axis. It's going to be vertical component, and this is in fourth quadrant, this is negative axis. The resolution of along vertical axis is going to be downwards. So this is going to be minus 800 sine of 50. Okay. And now again find out the vertical components of all these forces, resolve F1, F2 and F3 in vertical direction. I'll write it quickly. So this is going to be plus 400 sine 45 plus 300 sine 30. This is going to be a downward direction, and it is, so it's minus 500 sine 60, minus 500 sine 60. And then of course we have F4 which is unknown, so we find out F4, so then we'll write F4 sine theta with positive sign, because it's like introducing x. F4 sine theta, F4 sine theta. Okay, so this is our second equation. Now from these two equations, see, we want to find out two unknowns. Here two equations, two unknowns. You can find out F4 and theta by solving these two equations simultaneously. But also let's find out in which quadrant this force lies, because we would like to show that on the diagram. So to find out that, just find out the value of F4 cos theta from equation number 1. Find out value of F4 sin theta from equation number 2. And I am just writing those values here. So F4, after solving them, so you get F4 cos theta as 741.19. And this is positive. Please note, this is positive. And F4 sin theta is minus 612.66 newtons. So the horizontal component of force F4 is positive and the vertical component of force F4 is negative, which means the force is going to lie in fourth quadrant, because horizontal is positive, vertical is negative, only in fourth quadrant. And then all that you have to do is, once you find out this, you solve this. That means you divide one by another. That means you can divide F4 sin theta by F4 cos theta, and then you get time, F4 will get cancelled out. You find out value of theta, and you will also find out value of F4. So theta is going to be 39, and it's minus, but it doesn't matter, 39.59 degrees, and F4 is 961. 961.81. So we know it is in fourth quadrant, we know theta is 39, which means this is in fourth quadrant, and theta is always the angle which the force makes with the x-axis. So you can draw this. Let me use the black pen just to show that this is, so let's say this is our, and the value is 961, so this is 800, so I'll extend it beyond 800, and let's say this is F4, and this angle is 39.59. Thank you.